Okay, so for this question, the curve C has an equation y equals to ax over bx minus a, where a and b are positive integer constants with no common factor lah. Okay, show that C has a turning point at the origin O. So when we are asking about the proving that there is a turning point, this means that we not only need to show that your dy dx is equals to 0. At the origin will refer to the coordinates, basically x equals to 0 and y equals to 0. So from here, right, okay, first of all, we have to show that when x is equals to 0 and y equals to 0, this gives us the dy dx equals to 0. And not only that, we also need to show that this is not just a stationary point, but it's also a turning point, because the fact that do not stop at showing that dy dx equals to 0, because it can also be a stationary point of inflection. So if it's a stationary point of inflection, then it will not be a turning point. Don't worry, let me get into that very quickly. Okay, so first we have to the fact that they're asking for a turning point, so we need to find dy dx. So taking my dy dx here, now writing my y is equal to ax. All right, so I'm just going to split to let using the quotient rule. All right, I'm going to call my u as ax, therefore du dx will just be a, and v will be bx minus a, and dv dx would just be b. All right, so from here, usually I like to do my differentiation for quotient rule this way. I write the parts out individually, and after which I know that dy dx using the quotient rule would be du dx, right, which is over here, multiplied by v, subtract dv dx, multiplied by u. All right, so from here, oh, let me check, there's a square here, my bad. Okay, there is a square here, so I think I may have missed this out. There is a square here. All right, so that means this is u is ax squared, therefore du dx is 2ax. All right, so this will be 2ax, and this will be ax squared. All right, then my denominator would just be bx minus a, because it's v squared, so it's bx minus a squared. Okay, so from here, right, let's go on further to expand. I mean, I have expand this, right, 2ax to bx. This gives me 2abx squared. 2ax minus a, this gives me 2a square x minus abx squared over bx minus a bracket square. Okay, so from here, right, after that, how do we go about continuing is we now find the equate this to 0. And if you equate this to 0, okay, let's see first. Okay, first, if you observe this and this, they're actually the same, so they cancels out, and this gives me abx squared. All right, so if I equate this to 0, what do I get is basically the denominator does not offer me anything. I just simply the numerator, which I can equate to 0, right? So for a fraction, if I'm equating it to 0, the denominator will not bother me so much. Okay, so from here, let me factorize out x. Factorize out a, I have bx minus 2a bracket equals to 0. So you can see that I factorize out my a, one term, I factorize out x as well, one term. So here, either ax is equals to 0, meaning a equals to x equals to 0, or, because if I divide both sides by a, or I have bx minus 2a equals to 0, basically x is 2a over b. So you can see that indeed x equals to 0 does give us a turning point here. I would say turning point at the moment is a stationary point. All right, so because for me to show that it's a turning point, it must be a maximum or minimum. It cannot just be, I cannot just stop at dy dx equals to 0. So go on further to find your d2y dx square, and I'll leave it to you to do the differentiation. Okay, I believe I will not bore you with the differentiation. So d2y dx square is bx minus a square. you will find that when you sub x to be 0, then d2y dx square is none other than just 2a square over 0 minus a square, which is just, sorry, there's a negative somewhere, right? 2a cube, sorry, apologies. So there's a 2a cube. Alright, so it's a 2a cube. And if I sub x equals to 0, this is my d2y dx square, which is 2a cube over bx minus a cube. Alright, this will give me actually a negative 2, which is less than 0. So that tells me that my d2y dx square is negative 2 when x is equal to 0. And it proves that when x equals to 0, by the second derivative test, it will tell me that 0, 0 is a maximum point. And therefore, it is a turning point, right? So when we talk about turning point, we cannot just say that, we cannot just stop that dy dx equals to 0 because, sorry for having a short flu, okay, because it can also be a stationary point of inflection. So we have to prove the nature, okay? So let's look at part B. Right, given that C has another turning point at x equals to 5/3, find the values of A and B. Now remember just now, when we equated dy dx to 0, x can also be 2a over b. So what they are suggesting to you now is that this, right, this x equals to 5/3 basically represents this 2a over b, which is 5/3. So from there, right, okay, let me just add another platform over. Okay, so 2a over b, right, which is the other turning stationary point, basically is equals to 5/3. Simplifying this gives you b, 5b equals to 6a, cross multiply, and b equals to 6a over 5 lah. Okay, that's if I cross multiply. Okay, and from here, right, I mean, what else can we, how do we leverage upon this lah? With this information is, let's try with this. We can substitute. We know that y on original equation is y equals to ax squared over bx minus a. I substitute this as my b. Alright, so this is ax squared over 6a over 5 x minus a, which is the multiplying both top and bottom by 5/5, just to get rid of the fraction in the fraction. So why do I introduce this 5 is to get rid of the fraction here, right? So 5 and 5 here, that will give me 6ax. 5 and a, that gives me a minus 5a over 5ax squared. Okay, so what does that tell you? Simplify this further, is that if you compare this to the original equation, right? Okay, compare this to the original equation. Okay, this tells you that ax squared, okay, if I cancel all of them by a, cancel. Okay, common factor, this is just 5x squared over 6x minus 5. We note that in the question, they have stated that a and b are positive constants with no other common factor. So we are very sure that when I observe these 5 and 6, yes, they are no common factor. So if you turns out that you get something like a 10x squared over 12x minus 10, then these are terms with common factors, right? 2. Okay, so here we can conclude that because this and this, just by comparing the coefficient, you can see that a is equals to 5 and then b is equals to 6. Okay, right? So that's how you can handle this question. Thank you.